All right, this is section 7.4, approximating square roots. And when we're talking about square roots, we have to talk about rational and irrational numbers. And so a rational number is a number that can be written as a fraction. It's a pretty simple definition. Any number that can be written as a fraction. And so an irrational number is a number that cannot. So let's talk about the kind of numbers that can be written as fractions. Well, fractions, for sure, can be written as fractions. And so we have different kinds of fractions. We have proper fractions, and those are fractions where the denominator is larger than the numerator, so like 3/4 or 7/12. And we have improper fractions where the numerator is larger than the denominator. And these are the fractions that are larger than 1. And then we've got mixed numbers, and mixed numbers like 3 1/2 or 6 7/8, those can all be written as fractions as well. So all the fractions and mixed numbers that we worked with are rational. It also includes all integers. So 6, for example, can be written as 6/1, so that can be written as a fraction, and -5 can be written as -5/1, so that's a fraction. And then it includes most decimals. It includes what we call terminating decimals. Those are decimals that just stop, like 3.2 or -6.875, right? Those are all terminating decimals. They stop. And then there's repeating decimals. Now, repeating decimals go on forever, but they repeat certain numbers. So, like 0.2 repeating can be written as a fraction. It's actually 2/9. We'll do a section later where we actually are writing repeating decimals as fractions. Or 0.64 repeating, where the 6 and the 4 both repeat. Any repeating decimal can be written as a fraction. This would be 64/99. Which I've pretty much just given away the pattern right there. And so these are all examples of rational numbers. So now let's look at irrational numbers. You might notice those are pretty much all the numbers you've ever worked with in your math career, right? Proper fractions, improper fractions, mixed numbers, integers, terminating and repeating decimals. And so what does it mean to be an irrational number? Well, if the definition of a rational number is a number that can be written as a fraction, then an irrational number, again, is one that cannot be written as a fraction. And so there's really two different types of numbers that cannot be written as fractions, and those are non-terminating, non-repeating decimals, like pi is an example of that, and non-perfect square and cube roots. And so we talked about square roots already, and we know what a perfect square is. Those numbers like 1, 4, 9, 16, 25, 36, the list goes on and on and on. And so if I square root a number that's not a perfect square, like 24, for example, I'm going to get a non-terminating, non-repeating decimal. And so it'll look just like pi. And that's what's going to happen anytime I square root a number that's not already a perfect square. So rational and irrational numbers form the set of what's called the real numbers. And this diagram is probably one of the most important ones you'll want to refer back to as you're working through this section. And so real numbers are all the numbers that exist. And so rational and irrational are the two groups. So within the rational bubble, we've got, again, rational are numbers that can be written as fractions. So you can see this repeating decimal, this terminating decimal, this fraction, and these two proper fractions. Those can all be written as fractions. Integers can also be written as fractions. We just mentioned that. So integers are rational. And then we've got really two other terms we need to talk about. We've got whole numbers and natural numbers. So we'll start with natural. Natural numbers are the positive counting numbers. Positive there is a key because 0 is not positive. So the natural numbers I like to think of when I'm counting for hide and seek, the natural numbers are what I'm going to use. I'm not going to start counting at 0. I'm going to count at 1, 2, 3, 4. So those are all called natural numbers. Whole numbers are all the natural numbers plus 0. That's really the only difference. So this bubble shouldn't be as big as it is. It should look like this. It's pretty much just 0, right? It's the only number that's a whole number, but it's not a natural number. And then, like I mentioned, integers are all the positive and negative whole numbers. So all the positive and negatives, all the natural numbers plus 0, and then all the negative numbers are the integers. And so these are all called rational numbers. And then on the other side over here in blue, we've got the irrational numbers like pi, negative 2 pi. Here we've got the negative square root of 3. Of course, 3 is not a perfect square, so that's going to give us a irrational number. The square root of 2, and 2 is not a perfect square. The cube root of 7, and 7 is not a perfect cube, so these are all numbers that would be irrational. And so we call them real numbers because if a number's not rational or irrational, then it's not real. And so we talked a little bit about taking the square root of a negative number and how you can't do that. If you try to take the square root of a negative number, like the square root of negative 25, your calculator is going to say error. It's not going to let you do that because there isn't an answer for that. There is not a single number out there that when you square it, gives you negative 25. So this would be not real. And we mentioned that. And also dividing by 0, right? That's also going to give you, it's actually, we say it's undefined, right? You can't divide a number by 0. So that's another thing that would give you a number that doesn't exist. So in this homework, we're going to have to look at different numbers and classify whether they are rational numbers, whether they're rational numbers and integers, whether they're rational numbers, integer, and whole numbers, rational numbers, integer, whole number, and natural numbers, or if they're just irrational. So one important thing to remember is when I'm classifying these numbers, I have to make sure I list all the subsets in which that number belongs. So for example, 2 is a natural number. It's also a whole number. It's also an integer. And it's also a rational number. In fact, I could even say it's a real number, but we'll just assume that we're talking about all real numbers since it says classifying real numbers up here at the top. So these are some different examples. You can see the square root of 12 is irrational because 12 is not a perfect square. We talked about that. This was a repeating decimal, so it's going to be rational. Here, the negative square root of 9 is negative 3, so it's an integer, and it's also rational, so I have to include both of those. 72 divided by 4 is equal to 18, so it's natural, whole, integer, and rational. I include all 4 of those. And then pi is irrational, just like square root of 12 was irrational. So let's look at some different numbers and see if we can classify them, again, using all the subsets that number belongs to. And so 196 is a perfect square. It's 14 squared. So the negative square root of 196 is going to equal negative 14. And so that is not natural because natural numbers are only the positive numbers, positive counting numbers. It's not a whole number. It is an integer. And I'm totally fine with you abbreviating these. It's an integer and it's rational. And so that's what I'd put for both those, integer and rational. Example B, there is some repetition here, but there's not really anything I can put a repeating bar over. I see that it goes 1, 2, 1, 2, 2, 1, 2, 2, 2, 1, 2, 2. So we keep adding another 2 each time, but there's no spot that I can really put a repeating bar anywhere over this. And so because it doesn't constantly repeat the same numbers. And so because of that, this just is irrational, and I'm okay with you using IR for irrational. Example C wants to know the cubic root of 0, and the cubic root of 0 is 0. So that is not a natural number because natural numbers don't include 0. Whole numbers do. So we got whole numbers, we've got integers, and then we've got rational numbers again. That's what 0 would belong to. Example D, this is a terminating decimal, so it is rational, and that's it. It's not a whole number, it's not an integer, so it's just rational. Example E, 58 fourths, or 58 divided by 4. 58 divided by 4 is equal to 14.5, so that is another terminating decimal. So this one's just going to be rational, just like the last problem. And then I scroll down here a little bit. Example F, the square root of 72. Well, 72 is not a perfect square. In fact, it skips right over 72. We got 64, which is 8 squared, and then 81, which is 9 squared. So it skips right over that. So because it's not a perfect square, I don't actually need to see what it equals to. Since I know it's not a perfect square, I know it has to be irrational. I don't even have to see. I know it's somewhere between 8 and 9, but I know it's irrational. And then example G is a perfect cube. And if you type that into your calculator, the cube root of 729 is 9. And remember, we did cube roots back in our volume chapter. It's actually chapter 8 that we did at the beginning of the year. And so you guys should have a cube root button on your scientific calculators. Some of them might look like this, and I talk more about that in part 1 of this video, of this lesson video, so you can refer back to that. And so 9 would be a natural number. It would also be a whole number. It would also be an integer, and it's also rational. So it's all 4. And then the last one here, example H, I've got another repeating decimal. So because it is a repeating decimal with the repeating bar, I know that it's going to be rational, but that's all I can say about it. It's not going to be a natural number, whole number, or an integer. It's just going to be rational.